morning, students. So in my previous two presentations I have discussed about the structured programming approach, which emphasized on improving the clarity, quality and the development time of a program by making use of structured control flow constructs. The structured control flow constructs were the selection constructs, which makes use of the if and if-else statements, and the repetition or iteration constructs that makes use of the for and while statements. We have also come to know that programs developed using structured programming approach are easy to read and understand because of its clarity and simplicity. They are user-friendly, they are easier to maintain, and the development is easier as it requires less effort and time. Regarding this point number 4, I have already shown that to you by comparing two different programs, okay, that is program 1 and program 2. One with the structured approach, that is the program 2, and the other with the non-structured approach, which is the program 1. The development time gets considerably reduced with less effort and time using the structured approach. Then I have also discussed about the function-oriented programming approach, which focuses on the divide and conquer approach. Okay, so this is the function-oriented programming approach, which focuses on the divide and conquer approach. We have seen that using the divide and conquer approach, the main focus was on dividing a large problem and a complex problem into smaller and simpler tasks called functions or modules. And these small tasks were solved individually and integrated together to get the completed solution. Now see here the case of the railway reservation system. In this case, the main focus was on dividing the complex and the large problem of the railway reservation system into smaller and simpler tasks called functions or modules. Then these small tasks were solved individually and integrated together to get the completed solution, which is the railway reservation system. So that was just a brief cover-up of what has been discussed in the earlier two presentations. Now let's come to the topic of discussion for today's presentation, which is the object-oriented programming approach. The object-oriented programming approach combines both the approaches, that is the structured programming approach as well as the function-oriented programming approach. In addition to that, the object-oriented programming approach will have its own features. The fundamental components of object-oriented programming are classes and objects. We define classes as a blueprint or a template from which the objects are created. In general, a group of similar objects, okay, a group of similar objects is called a class. In the living world, we are surrounded by hundreds of objects. We ourselves are the living objects and interact with many living and non-living objects in our daily life. An object must have the following characteristics. The first one is the identity. This property of object differentiates one object from the other. Every object must have a unique identity. For example, in the above figure, every computer has a unique serial number, and this serial number becomes the identity of an object that differentiates it from other objects of the same class. The second one is the behavior. Every object performs certain activities. These activities are called behaviors or methods of an object. For example, data processing is a behavior of a computer. Data processing is a behavior of a computer. The next one is the state. An object can exist in more than one state. Okay. Now, for example, a computer can be in different states. For example, a computer can have the state as on, or else it can also have the state as off, and even it can have the state as hibernate or standby, etc. Now, in the given figure, we have three objects. All belong to the class computer, but all these objects, even though they represent the same class called computer, they are identified by different serial numbers. That is, the first object has its serial number as PC1, the second object has its serial number as PC2, and the third object has its serial number as PC3. Their behavior is the same, that is, data processing. But the first object has the state on, the second object has the state off, and the third object has again the state on. There can be more states as well, as I have mentioned, like standby and hibernation. Now take an example of a real-world scenario where mobile represents the class and its types, Nokia, Samsung, and iPhone represents the objects. In other words, an object can be described as a real-world entity which have their identity, behavior, and state. And a group of such real-world entities form a class. In this example, Nokia, Samsung, and iPhone are the objects. That is, they are the real-world entities, and a group of all these objects, that is Nokia, Samsung, and iPhone, form a class called mobile. In the given figure, Nokia is the identity of the first mobile. Samsung is the identity of the second mobile, and iPhone is the identity of the third mobile. And each of these objects have their own state, like on, off, and sleep mode. Here the state of the Nokia mobile is on, the state of the Samsung mobile is off, and the state of the iPhone mobile is sleep mode. In addition to that, they have their own behaviors, like calling, sending messages, and sharing stuffs like pictures and documents. As nowadays almost all the mobile phones have their own functionalities So is Nokia, Samsung and iPhone. All these types of mobile phones which are considered as objects of the class mobile have the same behavior, that is calling, sending messages and sharing. We can also use the term method. Okay, we can also use the term method to refer to behavior. Each of these objects interact with the class through some methods or behaviors that could solve real-world problems. One such real-world problem where objects interact with the classes through methods or behaviors is the dialing of a number for making phone calls. When you dial a number from your phone, it internally calls some method that will concatenate or join together all the digits that comprises the number and then display it on the screen. For example, if you try to dial the number, say 919049228802 from your phone, it internally calls some method. Let's say it calls the method telecall that will concatenate or join together all the digits that comprises the number, that is the digit 9, the digit 1, the digit 9 again, the digit 0, the digit 4, the digit 9 again, then the digit 2, the digit 8, the digit 0 again, and again the digit 2. So all these digits which comprises the number will be concatenated and joined together, and that is how the number gets formed, and which is done using a specialized method known as the telecall. And then the number gets displayed on the screen, that is this number gets displayed on the screen. So this is one example of a real world problem, and that is how the objects interacts with classes. The objects interacts with classes to solve real world problems. There are more examples of real world problems as well, and you will properly understand the interaction between objects and the classes that could solve real world problems properly when I will start the first Java program based on object oriented approach. As of now, just try to understand the theoretical concepts of objects and classes as I have explained in today's presentation.